Hello everyone, welcome to today's video. I'm Clifford Mwenda, a GMAT trainer in the Kenya Leaf program, and I've been doing statistics for this series, and this will be the last video for the series. We'll be doing more practice, and so we'll dive in and do more practice from whatever we've learned from the previous weeks. So without much further ado, let's jump in. And the first thing I'd like to talk about is the question format for the data sufficiency questions before we do any practice. Most of you guys have been asking what are the answer choices. So here are the answer choices. Every data sufficiency question has the same answer choices, and they're listed as for A, statement 1 alone is sufficient. But before we look into the answer choices, let's look how the question format for the data sufficiency is. And first thing is the question prompt. So for the question prompt is the question, if X is an integer, is X greater than 0? How many students? These are the two types of question prompts that we'll be having. These are two types of data sufficiency questions we'll be having. Is X greater than 0? That's yes or no. Therefore, this is a yes or no question. And how many students? These one are requests for a specific value, a specific quantity, and therefore this is a value questions. So there are two types of question prompts or question data sufficiency questions. There are the yes no questions, and there are the value questions. All right, and then we'll have the second part for the data sufficiency questions, the true statements. All of us are familiar to the statements, and you'll find these statements. You'll have to take one independently first. If it's statement 1, then determine if the statement is sufficient to answer the question. Check the other statements independently and evaluate as well the way you've done for this first statement. And then with respect to the sufficiency or not sufficient, whatever answer you find from the two statements, then you can find the answer choice that you're looking for. And mostly I usually write A, B, C, D, E and eliminate while tackling the statements. And these are what I'm talking about. They're usually the same for each and every data sufficiency questions, and therefore you need to master them. I'll be looking at these statements now. Not statements, but the answer choices. We have A as statement 1 alone is sufficient, but statement 2 alone is not sufficient to answer the question asked. That's the question prompt. Statement 2 for B, E alone is sufficient, but statement 1 alone is not sufficient to answer the question asked. All right. C, both statements 1 and 2 together are sufficient to answer the question asked, but neither statement alone is sufficient. And then D, each statement alone is sufficient to answer the question, that's alone. And E, statements 1 and 2 together are not sufficient to answer the question asked, and additional data specific to the problem are needed. So here are the answer choices. Please master them so that you can tackle these data sufficiency questions with ease and less time compared to when you require the answer choices each and every time. Okay, that's all for the data sufficiency question format. You need to go to your specific resources that you're using and know how you eliminate each answers or each of the answer depending on the sufficiency of the two statements. That's all for the question format from data sufficiency questions. And now let's jump into the video. Let's do some practice questions. All right, please pause the video, give it a try, and then I'll jump in. Right, a total of 22 men and 26 women were at a party, and the average arithmetic mean age of all the adults at the party was exactly 35 years. Average 35 years is average age, and the average age of the men was exactly average age of men was exactly 38 years. Which of the following was closest to the average age in years of the women? And so for this one, you can also think of it as total number of ages for the whole lot, 26 plus 20. 26 women plus 22 men, that should be 48 people in that party. So let's think of it as the total number of age. And how can you find the total number of ages for the men? That's 22 times for the men, that's 38. That's the total number of ages for the men. That this should be 22 times 38. We can leave it at that so that we can simplify the equation as we move on. And then we can find the total average for women for this question. So we need to think of it as the total number of ages for the women, so that you can have the total number of ages for the men, total number of ages for the women with 26 women times the average that we need to find for the women. All of the number of people in the room, that's 48, equals to the average of the whole lot of adults in that party. That should be 35. So we know that 22 times 38 plus 26 times the average that we're looking for the women equals to 35 times 48. So we can simplify this much further. So we can have, let's move to the left-hand side. That's 26 times the average for the women equals to 35 times 48. Subtract 22 times 38. And the average for the women is 35 times 48 minus this, like that, minus 22 times 38 all over 26. Right, now we can try simplify this. This divided by 2, that's 13. We can remove a factor of 2 from each of the expression. Since it's subtraction, by 2 this is 24, and by 2 this should be 11. We're trying to simplify this so that we can calculate this faster. Let's do the first one, that's 35 times 24. This is 70 times 12, doubling and halving. So this is 12 times 7, which should be 70 plus 7 times 2, that's 14, times 10, which is 840. And then we have 11 times 38. This one is much easier, so that you can have 380 plus 38. This is 8, 11, 418. Let's subtract this, so you can have 840 minus 418. This is 422. And for the average for the women, this 422 divided by 13. And what will be our answer? We can try divide that out. We're looking for the closest. So this is approximation. We can try also approximate what value can be close to 420. We know that 13 times 20, that should be 260. 13 times 30, this is 390. This is 39, 390. So let's add another 13. So 13 times 31, this is 3 plus 13, this is 3, 10, 403. 13 times 32, this one should be plus 13, this is 6, 1, 416. And then 13 times 33. Sorry about that. Let me write this clearly. Let me delete it. We have 13 times 33. This one should be add 13, this is 9. This is 2. This is 429, which is greater than 422. So we need something greater than 32, but less than 33. And that should be 32.5. We can just confirm that, so we can have 416, 13 divided by 2, that's 6.5. So I can have a 512 to 422.5. And what do we have? We have 422. So that's even closer than what we want. So that's even closer than 32, sorry. So we can have a D as our answer for this particular question. You can divide this out, but I prefer you just look at this approximation so that you can have a clear and clear thought, clear flow to answering this particular question. Right. Here's another question. Please pause the video, give it a try, then I'll jump in. All right. The weights of a set of moving boxes on a truck have a mean of 22 pounds. So we have a mean of 22 pounds and a standard deviation of 3 pounds. Okay, so we have a standard deviation question here. Another 2 boxes are loaded onto the truck, one with 26 pounds and the other one with a weight of 18 pounds. What effect does this have on the standard deviation of the weights of the boxes on the truck? From our standard deviation video, we talked about how adding new observations into a set will affect the standard deviation. Let's draw the same or similar scale that we used. We have the mean, the standard deviation to the right, that's 3. This distance is 3. So we can have, if the mean is 22, then a distance of 3, that should be 25, and a 3 below, that should be 19. So the best way to approach this is drawing how these data points, the new data points are situated on this scale of hours. So it can have one weight of 26 pounds. We have 25 here, so 26 is outwards. 26 is outwards. And then we have another with weight 18. 18 is less than 19, so that it's outwards. What effect does this have on the standard deviation of the weights of the boxes on the truck? Right, as you can see, the distance is 3 to 19, distance of 3 to 25, but we've added 2 data points, 18 and 26, greater than the standard deviation, or with a greater distance from the mean than the standard deviation, and therefore this standard deviation here is pulled outwards. Same applies to the right hand side, it's pulled outwards and increases the distance from the mean, and therefore our new standard deviation, we did it like that, it should be greater than our old standard deviation, and therefore this standard deviation increases as B says. So the standard deviation does not change. This is when we add data point at 19, or add another 19 and add another 25. That's when the standard deviation stays the same. The standard deviation decreases. This means when the standard deviation is between the standard deviation and the mean, or on the mean. So it's between the standard deviation on the left-hand side and the right-hand side, taking a value point between those, not including 19 and 25. That's when the standard deviation is decreased, right? And it's greatly decreased when you add a value or a new observation right where the mean is, right? Add a 22, that's when you decrease the standard deviation the least. So it's not possible, these are out of scope. So we have answer as B for this matter. Right. I hope that's clear. If it's not clear, please put it in the comment section, and then we can get to you as soon as possible. So here's another practice question. Give it a try, pause the video, and then I'll jump in.
You're watching Success with Bob Mwiti Show, presented to you by Upstech America. Upstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstechamerica.com. Upstech America, we wake you up to the unlimited potential.
Ada and Paul received the scores on 3 tests. On the first test, Ada's score was 10 points higher than Paul. So the first test, we have Paul's score plus 10 points. That's what we have as Ada. This is for the first test. Okay, and then on the second test, we have Ada's score was 4 points higher than Paul's score. Once more, Paul's plus 4. That should be Ada's score, right? And if Paul's average or arithmetic mean score, note that on the 3 tests was 3 points higher than Ada's average score on the 3 tests. We're talking about average score and not the score. And then Paul's score on the 3rd test. We have the 3rd test. Paul's score was how much? Bigger than Ada's. So we have Ada's plus which value here, right? So then Paul's score on the third test was how many points? How many points? Asked about points, not the arithmetic mean once more, higher than Ada's scores. So we have Ada scoring 10 points greater than Paul's score. The second test was 4 points greater than Paul's score. The third test, Paul should have scored greater points than others so that he can have an average of 3 points higher than others on each exam, so that after evaluating the total points, in the 3 tests, divide by 3. So total points of Paul divide by 3 is greater than total points of Ada divide by 3, right? That's the idea behind this question. So if you, Paul's average was 3 points higher, that means ideally from just evaluating total points of P divided by 3 should be greater than total points of Ada divided by 3 by 9 points. What do you mean by that? If the average was 3 points, so that you can have 3 points here, 3 points here, 3 points here, that means for the average, Ada's average on the 3 tests was 3 points less than Paul's average. And so Ada's average should be, not Ada's average, but Ada's points should be 9 points less than Ada's, or than Paul's score, right? For average score, Ada's points were 3 points less, but for the total points, Ada's points were less by 9, right? I hope you understand that. So 9 points plus Ada equals to Paul's points. All right. With that, since let me just repeat it. If Paul's average arithmetic score on the 3 tests was 3 points higher than Ada's average score, we're talking about average here. So it means Ada's plus 3 points for each test was what Paul achieved for all the 3 tests. So the first test, that's Ada plus 3, second test, Ada plus 3, third test, Ada plus 3. But in real sense, Ada actually scored better in the first test and the second test. So we have another, since we need 9 points and Ada's points were 14 points greater, so that you can pull this mean where it's supposed to be and have Paul's scoring better than Ada, then you'll have this 14 points that Ada scored plus this 9 points. So you can have 22 points. Not sure if that's 23 points. So you can have 23 points that Paul scored in the third test more than Ada. So you can have Paul times 23 or plus 23. That should be what Paul scored in the third test, so that you can have 3 points on average higher than others, or can have 9 points more than others' points, total points for the first, second, and the third test, right? So for that matter, our answer should be D, and therefore D is our answer. I hope that's clear. Let's try this other question. Please pause the video, give it a try, and then I'll jump in. All right, let's write down the answer choices for this one. This question. Set M consists of 100 numbers with a standard deviation of 10 and the mean of 45. So yes, it's a standard deviation question. So you have right there, the mean is 45. That's the mean, and the standard deviation is 10. So we have one standard deviation. The distance is 10, and the standard deviation is 10. This is 35, and this is the distance of the values, average values, so that you can have 10 to the left hand side and 10 to the right hand side. So you can have 55 here, And so adding 35 and 55 won't change the standard deviation. Adding 45 will minimize the standard deviation greatly, and adding any points greater than 35 or less than 35 rather, and greater than 55 will increase standard deviation from 10. Set n consists of 4 numbers. This for m, right? N has 4 numbers. If all the numbers in set n are added to set m, so adding these numbers of n to m, how does it affect? Will the combined set have a standard deviation greater than 10? Yes or no? Right? Now we're back to standard deviation and how new values affect the standard deviation. Right? The range of set n is 0. So for these 4 numbers, the range is 0. That means all the values in the set are equal. So you can have, if all the 4 numbers have a range of 0, that means you can have, say, 10, 10, 10, 10. So you can have the biggest value is 10, the smallest value is 10, subtract them, you can have the range as 0. 10 is greatly less than 35 and therefore increases the standard deviation. And what if we added the 4 numbers at the same and have them as 45? 45, 45, 45, 45. If you have 4 values the same as 45, this means that we've added 4 values at 45 and therefore minimizing this standard deviation greatly, and therefore will this combined set have a standard deviation greater than 10? For this matter, no, and for this other one, yes. Therefore, this statement is not sufficient for statement 1, and A and D are out. Let's move on to 2. The sum of the numbers in set n is 180. Interesting. So we can have 2 options here. Let's think of them as very small values and big values. You can have another 10, 10. You can have 10 plus 10, that's 20, minus this is 160. You can have 80 and 80, right? So you can, if add these values, we'll have n. These are the values of n, right? For 10, 10, 80, 80. So you can have 10, 2 10s here, and 80s right there, 2 80s here. So if you add this, the standard deviation is increased, right? What if this set of numbers n is 180 divided by 4? You can have 90 divided by 2, this is 45. What if you can have all the 4 numbers the same as 45, 45, 45? If you have all these numbers the same, then you'll have all these 4 data points at the middle at 45, and therefore decrease the standard deviation from 10 to a lower value. And therefore, for this matter, is for this 45, 45, 45, is the combined, does the combined set have a standard deviation greater than 10? No, definitely no. It will minimize greatly. And for this one, 10, 10, 80, 80, will the combined set have a standard deviation greater than 10? Yes, definitely. And therefore we have yes and a no. For this matter, not sufficient, because we don't have a consistent yes, consistent no, and therefore B is also out. So let's figure out if it's C or A. Combine the statements. We have a range that's 0, so the values are the same, and the sum of the numbers is 180. So we can have an 80 divided by 4, which was 45 from example 2. And since the range is 0, then all the numbers are or must be the same, right? So we can have 45, 45, 45, 45, and it's still the same issue where we have all the 4 data points at 45 and minimize the standard deviation from 10 to a smaller value. And for this, will the combined set have a standard deviation greater than 10? Always no, since it will be minimized greatly. Always no, this is sufficient. There's no chance that the standard deviation will be greater than 10. It will minimize from a 10 to a smaller value, and therefore E is out, and C should be answer for this question. I hope you got that question right. Okay, let's give this one a try. This is our last question of the day. A, B, C, D, and E. Please pause the video, give this question a try, and then I'll jump in. If P is a set of integers and 3 is in P, set of integers and 3 is in P, is every positive multiple of 3 in P? Positive multiple. Know that 0 is a multiple of every number, but we need positive multiples. So 0 can't be included. So is every positive multiple of 3 in P? Yes or no question once more. Yes question. And let's see how this plays out. We know that P has some values, so we can have A, B, C, but it also has 3, and then D, E, among others, right? This set P, right? Is every positive multiple of 3 in P? So we need positive multiples of 3. This should be a 3. 6 plus 3, that's 9, plus 3, that's 12, plus 3, that's 15, 18, and so on, like that. That's what we need. So for statement 1, for any integer P, for any integer in P, the sum of 3 and that integer is also in P. All right. So what does that mean? For every integer A, B, C, 3, D, E, and all the integers in P, if you the sum of 3 and that integer is also in P. So we'll have A plus 3. Since this is also in P, you can also have A plus another integer as A plus 3 plus 3 of that. You can also have A plus 3 plus 3 plus 3. That's what that statement 1 means, right? So if you have 3 in P already, then you can have 3 plus another 3. That's 3 plus 3 plus 3 plus 3 plus 3, 3 plus 3 plus 3 plus 3, and so on. So as you can see, this is 3, 6, 9, and 12 as you go on, 15. All these are in P. Remember, you also have this set and this set, all of them being in P. So therefore, P has a lot of values to infinity with the multiples of 3 and any other integer plus 3 included. So is every positive multiple of 3 in P? Yes, we have all positive multiples of 3 in P. This is this set that we need in this P. Set P doesn't include only 3, 6, 9, 15, 12, 15, all the positive multiples of 3, but also the other values that are in P plus 3 as you go on, and so on and so forth. So every positive multiple of 3 is in P. We need from 3 all the way to infinity, and that's what you get from that P that was included in set P. So for this case, this is sufficient. B, C, and E are out. Let's go to the second statement. For any integer in P, that integer minus 3 is also in P. So for this one, you can have A minus 3, A minus 3 minus 3, since this is already in P. I remember that A is also in P. So you can have A minus 3 minus 3 minus 3, and so on like that. Right? See, but you're not focused in this sequence of A. We're focused in what was included in P from the question prompt. That's 3. So we have 3, then 3 minus 3. That's 3 minus 3 minus 3, like that, and so on, so on. Right? So you have 3, 0, negative 3, negative 9, negative 12, negative 15, as you go on. So do we have every positive multiple of 3 in P? Are we sure the other values in there? We have, let's say, 9, 12, 15. Do we have them? No, we're not sure. Maybe they are, since we're told it's a set of integers. 3 is in P. So I'm not sure if 6, 9, 12, 15, 18, all the way is included in P. The only multiple of 3 in P that's shown is that 3 is in P. All right. So for this case, this statement 2 is not sufficient, and D is not our answer. Our answer here should be A for that case. So these are the practice questions that we've been doing on standard deviation, the mean, median, really is the more tested, but as you go on the practices, I hope I'll include more questions. Right. So yeah, that marks the end of today's video. We'll do more questions as we go on for future videos on statistics. For now, that will suffice for statistics series. You can also go through the description box, look for the links from the previous videos, let's say first part, second part, and the third part on statistics, and watch this video before tackling these questions. So you can have a gist of what statistics encompasses and what actual mean, median, mode, understandable distribution, and so on is, right? Thank you all for coming. I hope you enjoyed the video. Have a lovely day. Have a great week ahead. See you guys in the next video. Bye-bye.